In this video, we will learn how to find the particular integral of second and higher order linear differential equations with constant coefficients. Rule number 3. So what is rule number 3? Rule number 3 is applicable if your capital X is x some power m, where m is some positive integer. So here, in this case, how we'll get particular integral? So we will convert this 1 over f of d into the form 1 plus some other function of d into some power n, right? And then we'll apply binomial theorem, and whatever the expansion we'll get, we'll ultimately operate that over x power n. This is easy to understand along with one example, but before that you must know what is the binomial expansion. So binomial expansion is this. So if you are having 1 plus some p power n, then this expansion will be equals to 1 plus np plus n minus 1 p square by 2 factorial n minus 1 n minus 2 p cube by 3 factorial. Now let's understand this rule number 3 along with one example. So here, this is our example. This is non-homogeneous because capital X is x square, and this is of the type x power m. Okay. The first thing is to find the complementary solution. For that, we need to write the symbolic form. So what is the symbolic form? That is d cube y plus 3d square y plus 2dy equals to x square, right? And from here, we'll get d cube plus 3d square plus 2d equal to x square, y equal to x square. So what is my f of d? F of d is this, y equal to x square. Next is auxiliary equation. What is my auxiliary equation? That is d cube plus 3d square plus 2d equal to 0. From here, what will be the values of d? So if I factorize this, it will be d into d square plus 3d equal to 0. So your roots will be 0 and minus 1 and minus 2. So roots are real and distinct. So we know in this case what we used to have. Complementary solution will be, so complementary solution will be equals to first constant e power first root into independent variable x plus c2 e power second root, that is minus 1 into x, c3 e power third root into x, right? Now next is particular integral. So particular integral used to be 1 over f of d into capital X. So what is our f of d? That is d cube plus 3d square plus 2d into x square, right? So here we need to convert this thing into 1 plus some function of d power some n. Okay, we have to convert this to this form. So in order to have 1 here, what we need to do, we need to take that term common which is having the minimum power of d. So which term is having minimum power out of these three? So obviously 2d is having the minimum power. Now let us assume, let's say if you are having f of d as d plus 5 power 3, then what is the minimum power of d here out of these two? Obviously 5. So if constant is available, then we'll take constant common. So like for example, if your f of d will be d plus 5 cube, then I'll take 5 common. Okay, so 5 cube will be common. You will have, this will be 1 plus d over 5 whole cube, right? This is how we'll convert this thing to this form. But in my case, in this question, what is the term, which term is having the minimum power? 2d. So we'll take 2d common here. Okay. So if I take 2d common, what will we get? 2d is common. D cube plus 3d square over 2d, and here we'll get plus 1, right? X square. Now here, so here we'll just simplify that thing and we'll get this form. Okay. And after this, we have to apply this formula, this binomial expansion. So if I compare my function with this, what is my n? This is my n and this is my p. Okay, so what is the expansion? So apply this 1 by 2d, 1, my n is minus 1, my p is d square by 2 plus 3 by 2d, okay, plus n into n minus 1 means minus 1, minus 1, minus 1 over this 2 factorial. Okay, and p square. P square means d square by 2 plus 3 by 2 d whole square, so on up to infinity. I'm not going to expand it further. I'll tell you later on that why I'm not expanding this further. Okay, so 1 over 2d, here 1 as such, minus 1 into d square by 2. So what you'll get, minus d square by 2 minus 3 by 2d. This is minus 1, this is minus 2. So this is 2. 2 will be cancelled with 2 factorial. So what you'll get? So we need to expand this by the formula of a plus b whole square. So this will be d power 4 by 4 plus 9 by 4 d square plus 3 d cube by 2. Okay. Now we know this d is what? This d is actually operator. So this is the derivative with respect to x. Similarly, what is d square? So d square is derivative, second order derivative with respect to x, right? And similarly, what is d cube? D cube is third order derivative with respect to x, right? So these are the operator which will be operated over x square. Now what we will do, we'll take this x square inside, okay? So this x square will be here, here, here. So all these operator will be operator over x square, okay? So 1 by 2d, all this operator, like here we are having x square into 1. So here you will have x square minus this operator d square by 2 x square minus 3 by 2 x square plus d power 4 by 4 x square plus 9 by 4 d square x square plus 3 by 2 d cube x square, okay, and so on. Now see here, if I differentiate derivative of x square with respect to x, what will you get? 2x. Second order derivative of x square with respect to x square, x will be 2. If I differentiate x square 3 times, then this will be 0. Similarly, fourth order derivative will be 0. Fifth order derivative will be 0. In fact, every derivative higher than 2 order will be 0 for x square. That's why this is important to expand the terms up to the power of d, where you are having same power as of the x power. So here in my case, they have given x square. So we need to expand till you are getting the terms in the form of d square. Okay, that's why I have expanded up to this term only. I have not expanded this term. Okay, because in this case you will get d cube and further power of d, which are not required because everything will be 0. So if I substitute these values here, so what you'll get? This will be 1 by 2d x square as such. Now this will be second order derivative. So 2 by 2. Okay, second order derivative of x with x square with respect to x is 2 minus 3 by 2 x square. Sorry, here we are having d. I forgot to write d. So dx square, so that will be 2x plus fourth order derivative will be 0. Okay, and here again we'll get 2. And this is again because third order derivative of x square is also 0, and further all the things will be 0, all the terms will be 0, so we don't need to write anything. Okay, now if I simplify, this is 1, this is 3x, this is 9 by 2. Okay, so just simplify this. So after simplification we'll get 1 by 2d as such, and this will be x square minus 1 minus 3x and plus 9 by 2. Now combine these two terms, what you will get? 1 by 2d x square minus 3x plus 7 by 2. This is not a final answer because d operator is still there. Okay, so 1 over d into some function means what? 1 over d some function of x means integration of that function with respect to x, right? So by using this, what we will have? 1 by 2. So 1 by d into this means integration of this thing. So we will get integration of x square minus 3x plus 7 by 2 with respect to x. So if we differentiate this, integrate this, what we will get? 1 by 2 x cube by 3 minus 3x square by 2 plus 7 by 2x. And we will not add any of the constant here because particular integral is free from the constant. Constants are covered by the complementary solution only. Okay. So what is our complete solution? So this is our particular integral, and we know what is our complete. The complete solution is equals to complementary solution plus particular integral, right? So y is equals to, what is our complementary solution? Complementary solution was c1 e power 0x. So 0x means e power 0. Okay, e power 0 means 1 plus c2 e power minus 1 into x means minus x plus c3 e power minus 2x means minus 2x. Okay, and particular integral we already know 1 by 2 x cube by 3 minus 3x square by 2 plus 7 by 2 x. This is our final solution. So rule number 4. Rule number 4 says that if you are having capital X is equals to e some power ax into v. V is what? V is a function of x. Okay. So v can be sin ax, we can be cos ax, we can be x some power, okay, or it can be a combination of these function like it can be x power m sin ax, okay, or cos ax. So in this case, how we will get particular integral? So particular integral will be 1 over f of d e power ax into v. So here what we need to do is you just need to increment this d by a. And what is a? A is the coefficient of x here. Okay. So wherever you have d in f of d, just replace that with d plus a. Fine. One more thing here, we'll shift this e power ax to left hand side. Okay, as positioning of the functions are very important here. So because e power ax has been shifted to left hand side, that means this updated operator which you'll get after incremented this d by a, this operator will be operated over this function v. So we will proceed according to this function, like if this is sin ax or cos ax, we'll apply rule number 2. If this is x some power, we will apply rule number 3. Okay, let's understand this along with one example. So this is our example. Here what we will do, first thing is to write the symbolic form. So d square minus 2d plus 4y equal to e power x cos x, right? And next thing is, here we need to find the complementary solution, and for that we need to find the roots of auxiliary equation. What is auxiliary equation? D square minus 2d plus 4 equals to 0. Now what are the roots for this? So the roots are 1 plus minus iota. Okay, you can calculate this. So these are the complex roots. So what will be the complementary solution here? So complementary solution is e power real part. What is the real part? This is your real part. So 1 into independent variable x into first constant cos imaginary part. What is the imaginary part? Imaginary part is along with the iota. That is also 1. So 1 into x plus c2 cos, sorry, not cos, sine 1 into x, imaginary part into x. Okay, so our complementary solution is ex c1 cos x plus c2 sin x. Okay, now what is next? So next we need to find the particular integral. Alright, so what will be the particular integral? So particular integral is 1 over, here what we have, f of d is equals to d square minus 2d plus 4, and what is our capital X? Capital X is e power x cos x. Okay, now compare this with this. What is our v? V is cos x, and what is a here? A is 1. So if I compare this e power ax with this, what is our a? A is 1. What we need to do according to this formula, we need to increment this d by 1, and we will shift this e power x over left hand side. So this will be e power x 1 over d plus 1 whole square minus 2d plus 1 plus 4. Okay, and here we'll get cos x. Now here you will get e power x, solve it. So this will be d square plus 2d plus 1. Here we'll get minus 2d minus 2 plus 4. So this 2d and 2d will be cancelled. Cos x as such. Here we'll get e power x 1 over d square, and what is this? This is 5 minus 2. This will be minus 3, sorry, plus 3 cos x, right? Now this operator will be operated over this. So if you are having cos ax or sin ax here, what we used to do in that case? So by applying rule number 2, we have to put d square is equals to what? So put d square is equals to, what is a now? A is coefficient of x. So here coefficient of x is 1. So here we need to put 1 square negative. So that means minus 1. So put d square is equals to minus 1 here. So what will we get? E power x 1 over, what is our d square now? D square is minus 1 plus 3 cos x. So what we are getting? This will be e power x 1 by 2 cos x. Okay, so now this is free from d, so that means our particular integral is e power x by 2 cos x, right? So we have already done the complementary solution. So what is our complete solution? So the complete solution is complementary solution plus particular integral. So what are complementary solution? Complementary solution was c1 cos x plus c2 sin x, and here we were having e power x, right? Plus particular integral come out as e power x cos x by 2. So this is our final answer. Okay. Now let's discuss rule number 5. So rule number 5 is applicable if on the right hand side your capital X is given as small x, means independent variable, into some function v. V is what? V is a function of independent variable x. Okay, in this case how we will get particular integral? So this particular integral will be split into two terms. So one is when we shift this x on other side like this, okay, on left hand side, and we'll keep this 1 over f of d as such, and we proceed according to this function v, okay, and plus we will differentiate this 1 over f of d with respect to f of d, and whatever the updated operator you will get here, that will be proceeded according to this v, right? So one thing which we need to observe here, we are not differentiating here f of d, we are differentiating 1 over f of d. Alright, and this v can be sin ax, cos ax, e some power ax, right? So let's see how we will apply this rule along with one example. So this is our example. So d square y over dx square minus y equals to x sin x. So here what is our capital X? This is our capital X. And what is our v? V is this thing, sin x. Okay. So first thing is the complementary solution. So d square minus 1 into y equals to x sin x is our symbolic form. Now auxiliary equation will be d square minus 1 equal to 0. From here we'll get roots as plus minus 1. So what will be the complementary solution? So complementary solution is c1 e power minus x, because these are the real and distinct roots. So first root minus x plus c2 e power second root, that is 1 into x, right? So this is our complementary solution. Now let's see how to find the particular integral. So particular integral will be equals to 1 over, so what is our f of d? So this used to be 1 over f of d into capital X. So f of d here is d square minus 1 x sin x, right? Now here by applying this rule, what we need to do, first of all we'll shift this x on other side. So here you'll get x 1 over d square minus 1 sin x, okay, v is sin x, plus second term is we need to differentiate 1 over f of d, okay, so derivative of which function? 1 over d square minus 1 into sin x. Fine. Now here what we need to do, we need to find this thing first. Okay, so let's see how to find this. So the derivative 1 over d square minus 1 is actually equals to derivative of what? Can I write this thing as d square minus 1 raised to power minus 1? Now differentiate this. This will be minus 1 d square minus 1 power minus 1 into, by chain rule, derivative of this thing, that is 2d. So if I solve this, this will be minus 1 or minus 1 into 2d, that will be 2d, right? So here you'll get 2d over d square minus 1 power minus 2. Okay, so now replace this value, put this value here. Okay, so what we will get? We'll get x as such 1 over d square minus 1 as such, sin x as such, and here we'll get minus 2d d square minus 1, here we have, sorry, here we have positive 2, and sin x. Okay, now we will proceed according to this function, and in both the terms we are having sin x. Okay, so in case of sin x or cos ax, what we used to do, so here we will apply rule number 2 again. So we need to put d square is equals to, what is the coefficient of x here? So here coefficient of x is 1. Here also coefficient of x is 1. So in both the terms we have to put d square is equals to 1 square negative means minus 1. So what we will get? X as such, this x as such, okay, 1 over this d square will be minus 1 now, along with that minus 1, right? And here we have sin x minus 2d. Here again d square we'll put minus 1 whole square, and here we have sin x, right? So this will be minus 2, so minus x by 2 sin x, and here minus 2 whole square, so this will be minus 2 by 4 d sin x. What is our d here? So d I know. D is derivative with respect to x. So d of sin x, this capital D sin x means what? That means derivative of sin x with respect to x. This is equals to minus x by 2 sin x. Okay, and this 2 will be cancelled here. So there will be minus 1 by 2. What is the differentiation of sin x? That is cos x. Okay, so now this answer is free from D. That means this is our final answer for particular integral. Okay, so what is our complete solution? So complete solution will be equals to, we know complete solution is complementary solution plus particular integral. So what was our complementary solution? That was C1 e power minus x, C2 e power x, and what is our particular integral? This is our particular integral, right? So what we will get here? So minus x by 2 sin x minus cos x by cos x, here we don't have space, so minus cos x by 2, right? So this is our final answer. This is equals to actually dependent variable y, right? So these are the 5 rules. In next lecture we will discuss rule number 6 along with one example. Thank you very much. This is all from my side. Thank you.